Okay, so for lesson 2-5, we are looking to take vertex form and rewrite or convert our equation into standard form. For your essential question, I want you to explain step by step the process of writing vertex form into standard form. So just real quick, a couple of vocab terms that we've actually already seen. I just want to make sure that we're entirely familiar and we know what I'm talking about when I use these terms. The first one is vertex form. And we know that vertex form is y equals a times x minus h squared plus k. And then standard form, which we talked about at the very beginning of Unit 2, is y equals ax squared plus bx plus c. Now, notice that we have x's and y's in both of the equations, and we have a in both of the equations. Now, the a that you see in vertex form is the same value of a that you see in standard form. Those are the same values. So when you convert from one form to the other, those two values should always be the same. Now, the h and the k will no longer appear in standard form when you convert it. So we have some value of x, and then we have our constant c at the very end. And remember, the constant is the number without the variable. So the difference between these two is that in standard form, you no longer have parentheses around your values. And so we have this binomial here that's being squared that we have to get rid of in order to work towards putting our equation in standard form. So that's what we're going to work on for our guided practice problems today. So our first GP is to take the equation y equals x plus 5 squared minus 4 and write it in standard form. So again, we need to take this binomial squared and do something with it to get rid of those parentheses. Now remember, when you have a binomial squared, what that means is we're looking to multiply the binomial times itself. Now, if you're really good with your special patterns and you feel comfortable using your special patterns to multiply these two binomials together, then please feel free to do so long as you find that you are accurate when you do that every time. Otherwise, I'm going to show you how to multiply these two binomials using double distribution. Now, this -4 is going to kind of hang out here until the very end. Because remember, according to the order of operations, we have to start with parentheses. Well, there's nothing to be simplified within our parentheses. We cannot add x and 5 because they are not like terms. From there, we use exponents. So that's why I took my binomial and I separate it to x plus 5 times x plus 5. Therefore, I'm using the exponent because it's telling me I have to multiply the binomial 2 times. From there, we have to do multiplication. So this 4 is being subtracted, which means that I'm not going to do anything with that 4 until the very end of my simplification process. So I'm going to go ahead and double distribute my binomials. X times x plus 5 plus 5 times x plus 5. So I distribute this x. X times x gives me x squared. X times 5 gives me 5x. 5 times x gives me 5x again. And 5 times 5 gives me a positive 25. So I simplify and I get x squared plus 10x plus 25. And then I can take this 4, and now that I have simplified everything else, I can now go ahead and I can subtract that 4 from its like term, which is the 25, because they both do not have a variable on them. So that ends up giving me y equals x squared plus 10x plus 21. I'm sorry, yes, plus 21. And this is the equation in standard form. Now, in your practice for today, I am going to ask you to identify the constant as one of the answers. So remember, your constant is the number without the variable. All right, so for this one, we're doing the same thing. Write the following equation in standard form. So following the order of operations, the first thing we have to do is parentheses. But again, we cannot subtract 3 from x because they are not like terms. So we're going to move on and we're going to use the exponent. So the exponent is telling us that we have to multiply x minus 3 times x minus 3. You have to multiply x minus 3 2 times. So I'm going to break this part and I'm going to double distribute. Now we don't want to forget to bring these other 2 numbers with us. Even though we can't use them just yet, we do have to use them when we get to a certain point. So I'm going to go ahead and double distribute x minus 3 times x minus 3. So we have x times x minus 3 minus 3 times x minus 3. So this gives me x squared minus 3x minus 3x plus 9. When I combine my like terms, I get x squared minus 6x plus 9. Now again, I still have this plus 6 that I have to add at the very end because addition's not till the last step. But then I also have this negative 2 that I have to multiply to my new polynomial here. Now we have to do the multiplication before we do the addition. Multiplication is the next step in the order of operations. So you have to make sure that you are multiplying your a value before you are adding the k to your polynomial. And that's where a lot of students get mixed up because they try to add this value before they multiply. But again, you have to follow the order of operations. So from here, we're going to go ahead and distribute that negative 2 into the parentheses. So I'm going to distribute the negative 2 to all 3 of these terms. When I do that, I get negative 2x squared. Negative 2 times negative 6 is a positive 12x. And negative 2 times positive 9 is a negative 18. And now that I've taken care of everything else, I can go ahead and add that 6 onto the 18. So my standard form is y equals negative 2x squared plus 12x minus 12. And that is the equation in standard form. Now, once again, if I ask you to identify the constant of the equation, the constant is that number without the variable. So the constant of this equation would be negative 12. Now, don't forget to make sure that you add toolbox items to each of your GPs, as well as answer the essential question now that we're done with the notes.